Alright, so the last video was 38 minutes long, so that might not end up on YouTube, because that might be a little bit too long. I mean, it doesn't really matter anymore, because I don't think anyone's watching this, so this documentation is mostly for myself. But yeah, let's keep on going. Okay. Pulling on the top and pulling it in on itself. We got to locate the top edge. So that would be y0, right? Because top left origin is y0, x0, or sorry, x0, y0. And to pull in on itself, hold on. Yeah, to pull in on itself, we would do plus, right? Because plus is going to move down screen, and that would move down into itself. Okay, yep, that's good. So pull on the bottom. We got to locate the bottom edge, so that's going to be y1, and we need to move up screen. So minus equal, that is correct. Okay, let's keep going. Push left. We got to locate the left edge, so that's going to be x0. And okay, we're pushing instead of pulling now. So it's as if we were inside the rectangle and we're locating the left side, and then we're moving it further to the left. So that is correct. Push right inside of the rectangle, find the right edge, push it further to the right. That is correct. Push top, you're inside the rectangle, you find the top edge, and you push it further up screen, and that's a minus equal to go up screen, so that's correct. Push bottom, you're inside the rectangle, you got to find the bottom of the rectangle, you got to push it further down with the plus equals to go down screen. That is correct. Okay, so let's see, global event key number, we already went over this. Fetching the editor shader code. That looks... I may have made some changes to some of this, and then some of the breakpoints got removed. Testbed shaders prelude. This is definitely new. Right here. So I have some variables that I'm going to use in my testbed shaders. So TBS is for testbed shader, and this is testbed shader time, and this is testbed shader, I believe, normalized coordinate or normalized color. And I'm intentionally making it ambiguous as to whether this means color or coordinate, because sometimes I want to warp my shaders around geometry by changing the colors that are associated with the axis progression. What else? So TBS stands for testbed shader, right? So this is testbed shader time and testbed shader normalized coordinate or normalized color. And the reason why these are normalized values, both the time and this value, is because it's more common for shader logic to be using normalized coordinates. So I used what is most conducive to sketching out shader logic. So when I'm doing a shader tutorial, these values are most likely what are going to be used as the inputs for the shader. And then there is also an output, but I don't see that anywhere. Because this is the... Oh, it's right here. So this coloring is quite confusing, but this is testbed shader output. So this is the output variable that will set in those different testbed shaders. So this one here, right here, so it is... that is quite terse. So I believe that is fragment fetch test gallery input argument dex sha. So that means that it's going to be a fragment shader fetch for the test gallery using an input argument of shader index, and the shader index will be 0. So it's saying that this variable here is 0. Right, yeah, because this is the actual hard-coded shader code, and now that we're outside in the JavaScript here, so we can't just take this variable right here and just plug it in here. So there is a little bit of kind of like ugly hard coding, but you know what else? This is pretty dead simple logic right here. So it may not be elegant, but it's very easy to understand. So this shader right here, number 0, that is actually what you're seeing right here. That's shader number 0. And then if we scroll all the way down to shader number... Oh, actually, no, that's shader number 1 on my keyboard. Because it's keywords 1 through 9 and then 0. So yeah, this is shader number 1 right now. And then shader 0 is, like if we go to press 0, this is shader 0, just the memory debugger. Okay, so going back here, so here's where we get all of these little demo shaders, right? So editor 1 is the testbed shader code, right? So editor 1 is just an editor that lets me have a place to put shader code that I want to experiment with and have a little gallery that I can flip through. That's all it is. It's a very simple editor, but it also has some type of use because I can use this for development. And the idea is that you want the first editor to be very simple so that you have you have a prototype, like a template to work off of, right? You want, if the first editor was very complex, it would be hard to get the general structure of the editor in order to make more editors. Now you might be saying, well, just use inheritance, and you would be right, but I'm not using inheritance. Conceptually, I am using inheritance because there will be a very strict structure to how the different editors are laid out, so there will be commonalities, but those all have to be meticulously enforced by me. And the reason why I'm doing that is because I want to keep a dead simple approach, and I also want to put this into C code eventually. Okay, so where are we? So this is the fragment test gallery shader code fetching for the different shader indexes. And so it's pretty simple, right? We have a shader code string that is empty at first unless we hit a valid shader index value. So this is the shader code for the memory inspector. And then I really don't want to go over this. Let's just keep going. What time? Okay, 8 minutes, 20 seconds. So the shader with all the... right, this shader right here, this is from the tutorial that I was doing, Lewis Lepton tutorials. And I added my own little flair to it right here to kind of like colorize it a little bit, because the original tutorial is just black and white. So just, having some fun, after, getting down enough foundation to like, have, right, none of this code here is necessary. It's just like taking a break and doing some tutorials and, having a little bit of fun after, getting all of this structure in place. So all of these other shaders are just stubs, right? Like, there's no need to put any code here, because the idea was just to make a simple editor that can display different shader code, but there's no requirement for me to actually put any complicated shader code in here. I just have these empty slots that if I need to experiment with some shader code later, I can use one of these empty slots, right? These shaders just flash, they just strobe color. right? They just strobe solid blocks of color, very simple. And I can replace them with something more detailed later if I ever come across some shader code I want to inspect and look at. And in fact, I probably will be using this next shader slot here for like a Mandelbrot set so that we can get something that will work well with the zooming in and out aspect of our viewport rectangles, because I want to be able to test out those viewport rectangles and make sure they are behaving as I expect. And the best way to do that would be to have some type of fractal structure that we can zoom in and out of. So like a Mandelbrot is perfect for that. So we'll probably try to figure out how to do a Mandelbrot shader pretty soon. Okay, so what next? Okay, so IXY data structure. So just storing a coordinate both as its index value and its XY value. So it's index here and then its XY value here. You might wonder why there's an II, a XX, and a YY. That's just an OCD thing to keep all my variables aligned. I'm just keeping a very strict pattern of, right, how you see how these variable names are usually segmented and they're clustered in groups of 3. So I'm just trying to keep that consistency within my variable naming. So this is almost like a naming convention, but it's like a visual style based naming convention. Okay, our inclusive rectangle, right? So our left edge, top edge, right edge, and bottom edge. Global event. Let's keep on scrolling because we've been over most of this. Did we add something new to global event? This is relatively new, the bit patterns that kind of help categorize and allow us to use a union-like pattern to these events. Configured structs. Okay, okay, this is for making our hot swap rectangles. So I was, to avoid a proliferation of prefixes, I decided we'll just call it new rectangle inclusive and then add further qualification on it. This makes it easier to understand what it does right away because we haven't added a new prefix that we have to remember. And so we can look at this, automatically know what it does, and then the more vague, or the, not more vague, but the less common prefix here. Well, if it's less common, don't make it a prefix, make it a postfix, right? So that you can go from broadly known knowledge to less commonly known knowledge, right? So MAD is for made into. So I could have just called this function something like make rectangle hot swap or something like that, but I don't know. I just thought that this was, even though this is kind of weird, I thought that this was the most understandable for me, so that's what I chose. Okay, let's keep on scrolling. Okay, so the loop table, nothing has changed with this. Okay, so we're in the classes section, adapter variables. I don't think anything has changed here. Okay, now we have a whole bunch of breakpoints. So a lot has changed here. So these are the publicly exposed getters and putters for the different data points for our viewport rectangles. So VPC, right, is our viewport canvas. And we have something that can get us the entire rectangle by you pass it a rectangle to like load up with the data, and then it will load it up. Or you can get each individual point of the rectangle one by one, which I don't think I'll be using anywhere. But anyways, obviously it's a lot of code, but it's very redundant and not that complicated. So same deal for all of the other rectangles. So viewport 0, getters and setters, or getters and putters, whatever you want to call them. Okay, let's go down, and then we have the same thing for viewport number 1. Viewport 0 is the on-screen viewport, and viewport 1 is the off-screen viewport that's looking over your data. And I might get another viewport number eventually, because I was thinking of how I need viewports to be used. Okay, so this name has been refactored, right? So I'm using all uppercase edit 0001 to stand for editor number 1. And these are editor number 2 variables. And this is, we're slowly getting to re-implementing what was in the previous playlist. So the tile exponent and the tx and ty, these are like, they're ready to go. So we're pretty much ready to work on the next editor. But before we work on the next editor, I want to make sure that the rectangle operations are working properly. But we'll get to that eventually. Okay, the render mode, the editor mode, the game time. Okay, so this looks quite cluttered, and you might look at this and it might be confusing. The thing is, it was more important for me to have this column of variables lined up nicely than it was than anything else. And why is that misaligned right here? Okay, there we go. So if you look at it, you can see that this is the getter and putter for the canvas viewport dot x0 coordinate. And so function, and then we can see put here, and then we have function, and you can see a get here. Obviously, the indentation is completely it may look like the indentation kind of sucks, and it does. And the indentation, I made a compromise, right? I said, okay, the most important thing for me is to somehow to get this same variable name lined up like this. And, well, we can't get that and have perfect indentation. So, but the thing is that all of this code is just completely duplicated, and the only thing different about it is this column of variables. And if that's the case, that means you only have to expend a whole bunch of energy to figure, all this convoluted mess out once, and then you can look at these patterns and be like, okay, the only thing different is this, is this, is this. Now, if you didn't write the code, you might waste some time at first, because you might not trust that, right? And so you might be inspecting these parts to make sure that they're the same or not. But I wrote this so I know that it's all the same. And I even used a script to auto-generate it. So I know I didn't make any typos when I typed it, because I didn't type it. I used a generator that would take a template and then put in different variable names based on that template inputs. But yeah, so there's a lot of stuff here. Right, so let's see, this is all the canvas viewport all the way down to here. And so this is like a meta function, right? Because it's going to take the you're gonna load it with a rectangle, and then it's gonna populate every single data point on that rectangle by calling those previous getters. Or sorry, putters. Okay, this is the putter one, and then this is the getter one, right? So you notice that where I have my function keyword, it's kind of glued in there, and that's very intentional. I wrote it this way so that it would be very difficult to separate the getter from the putter, right? Because I don't I don't want the getter to ever be separated from the putter. That would make absolutely no sense, right? Because you want to easily see the symmetry, or in this case, the complementariness of the putter and the getter, right? Because they should be complementary. And since they should be complementary, you should be able to see them both at the same time, and therefore they should be paired next to each other. And we did some of the same alignment stuff over here, right? Okay, so the same exact thing, except for, this is for viewport 0. So same exact code, viewport 0. So I'm not going to go over it because it's very redundant. Okay, and then the same exact code for viewport 1, very redundant, right? So there's a lot of lines of code here, right? There's like, right, there's hundreds of lines of code here, but what's being done is dead simple, right? So it's a lot of code, but don't be afraid of a lot of code, because what's being done here is just very straightforward and very simple. Now we could try to like write some type of thing to like save us lines of code by like making some weird function utility class or whatever that kind of like does all of this redundancy for us. But from my experience, that would be a horrible idea. Right? This looks ugly and horrible, but I'm going to say right now this is the best way to do it. Because if you try to make some type of generic utility, you're adding, first of all, you're adding one more layer of abstraction to your code. So now your code is harder to understand. And you could possibly have some type of bug in that generic utility. And so now you got like bugs that you got to hunt down. So you're adding, okay, oh, and you have to take the time to actually write that and think that out, right? So this is a lot of code, but it's like basically cut, paste, right? So it's not like hard work. You know, double bonus if you're getting paid per lines of code. So, you know, maybe there is some advantage to using lines of code as a metric, because it will help people keep their code dead simple, right? So like an unintentional good consequence of using a horrible metric to measure progress. Okay, so anyways, viewport 1 stuff. Okay, so what are we? So after the viewport 1 stuff, what do we have? So this was just refactored. I believe just the name, right? The edit 001 right here. So I believe I'm just putting, these are just breakpoints by those refactor points. Okay, so this is the same exact pattern as before, but we have it for the tile exponent, the tile x, and the tile y, so I'm not going to go over that. Now you will notice that instead of it being editor 1, we have this editor 2 now, but it's still the same exact type of pattern. How much time we got? Okay, we're at 22 minutes. So editor all, that's the main editor. So when no other editor has control, editor all will at least be responsive. But editor all's main job is just to route input to the other sub-editors. Depending on which sub-editor is in focus, it will route messages to that editor. So like editor 1, editor 2, editor 3, etc. are sub-editors, and they only get inputs if editor all decides to forward the inputs to them. So it's kind of like a messenger pattern, except not everyone gets a chance to look at the message, right? Because a messenger pattern is like, oh, the message gets chained around, and then each object on that messenger chain gets a chance to look at the message and say, oh, is this message for me? And then if it's for you, you look at it and do something with it. It's not quite that kind of pattern. It's not a broadcast, right? It's like a targeted broadcast. It's there's probably some type of like terminology for what this is. So I don't know what to tell you. You know, I read some of the design patterns. I don't think I got through the whole book. Maybe I should pick it up and read it again. But but I don't know, man. I've done so much of this. Like I know what kind of designs I need in my code. Maybe I don't have the right words for the designs I use. But I don't know. I mean, come on. In the industry, what design patterns do people really know? MVC. Like MVC and messenger pattern, probably. I guess event listeners technically are a pattern. Anyways, I'm ranting. Let's keep on going because this is painful. So we're gonna keep on going, and I'm just gonna see if anything is different. Well, we could change the spacing there. Yeah, put a little space there. Okay, so that's just... I like it so that my cursor is kind of like in the middle, where it has padding, equal padding on both sides, so equal amount of white space. If you didn't notice, I like things very symmetrical. Let's keep going. Okay, editor base. So this is, right, we're not going to be using inheritance in JavaScript, but I still thought it would be good to create a base class that would kind of be a little guide blueprint to go off of. And we already kind of went over this in a previous video, so I'm not going to go over it. So here's editor 1. And we're starting to add some logic. So those functions we went over earlier about rectangle manipulation, we're going to assign all those different functions to some keyboard values so that we can manipulate the viewport on a shader in the shader testbed code and kind of see some results. And this is why the next thing I want to do is like make a Mandelbrot shader so that we have something that will give us some decent feedback. Now, you might be saying, well, Mandelbrot is pretty overkill. Well, no, it's not. Mandelbrots are easy. Right, so left, right, up, and down events, and then the, so you notice that this says PIXEFOG. That stands for pixel fog. And the concept there is the object does not actually exist. This object does not actually exist as a struct in the code anymore. It exists scattered amongst the pixels in the data in the pixel array that is synced with the GPU memory, right? So this basically, this object exists encoded as pixels in a texture now. It does not actually exist as a struct anymore, so it is somewhat conceptual of an object now, and so I use this pixel fog prefix to kind of let me know that it exists scattered amongst the pixels in the texture now. But if we go up here, what we have is we do have an actual instance of a rectangle, but this is private, first of all, and it's very intentional that it's private because I don't want... this is basically a temporary cache of the encoded viewport dimensions on the GPU texture. So let me go down here. The first thing we're going to do is we're going to... This would be like a... You could think of it as like a SQL query, right? We're gonna query the value in our database, but instead of a database, we have a texture. And so we're going to get this viewport rectangle value off of the texture and load it into this struct so that it's easier to work with. And now that it's loaded into this struct and easier to work with, we can do all these keyboard event listener commands with it, zooming in and out, and then the side walls, pulling them in. I need to also add something for pushing the walls, so I don't know how I'll do that. Maybe just use like I guess the other hand, so that would be like IJKL probably. Yeah, I'll probably add IJKL in there. So I'm gonna I'm going to make absolutely sure I get this in here. So I'm just going to add throw. And then, oh god, my fingers hurt. Add IJKL bindings. Okay, that way I won't forget about it. So I added a little throw in there. So this is like a to-do, but a very obnoxious to-do. Because I absolutely don't want to forget that. How much time we got? Okay, we're at 30 minutes. I'm going to stop recording and start recording again.